Welcome back to another tutorial. I am here today looking back at what I did just the other day in the vector field space. There'll be a link that you can look up here to my prior video. So this will be the second installment in that series because I received a number of questions, and I myself had posed this question myself about how I can take these vector fields and actually manipulate geometry and whatnot in them. So I will try to achieve that now. What you're seeing on the screen is what I did in the last video. I kind of went over and I think I added more complexity and showed you sort of what everything meant. But what I'm going to do is just like show quick methods of starting to achieve three-dimensional space rather than either a series of vectors like we saw before, or a series of like something like field lines, which can be diagrammatic but not necessarily the most useful. So this is all constructed in the last video, so please check that out and then let's move on. So what I'm going to do is essentially, so we have a series of vectors, which right now are represented by a ton of these field lines, but we can just visualize those vectors. For example, if we go to the vector set, we did this before. Let's just bring in this tensor display, bring in the field. Bring in, what is this? So I'm just going to bring in the original thing. And so this shows where the vectors are, and I'm actually going to hide this field lines for now. So we can actually use these vectors to geometry using these vectors. So you could use NURBS and use sort of the control points to try to do something like that, rebuilding surfaces. I'm not a huge fan of that. I'm more a fan of manipulating mesh surfaces. So for this instance, I'm just going to use mesh surfaces because I feel like we can use that resolution, and it's really easy access to the vertices and the faces to manipulate. So what I'm going to do here is build a mesh surface, and I can just bring this curve in, represented as a mesh surface. I need to create some U and V's. So I'm just going to duplicate this. So now I have a mesh surface with 25 by 25 U in the V direction. And I could rebuild this. Right now I'm just going to work with a surface. And actually I'm just going to bring this into perspective mode so we can kind of see more exactly what's going on. So what I have now is I have this mesh, but I need to manipulate the vertices of this mesh. And to do that, we can deconstruct the mesh, which I always deconstruct mesh right there. So we can deconstruct this mesh, and now we have access to the vertices, faces, colors, and normals. And right now we're going to be concerned with the vertices. So what I want to do is now I don't need to use this grid anymore. So what I'm actually going to do is supplement these vertices as that list of points. Vertices and points are essentially the same thing. So I can use this set of points to recalculate those where those points are, and we can and so well, I guess I can leave that field line there, but for now that doesn't really matter. We don't need to use the field line, and actually I'm going to delete this guy. He's just kind of hogging up space. The one thing we need to do is we need to bring in, actually be able to use that vector. And what this field line thing does is it outputs a series of polylines that describe that curvature, but they're not vectors. These are explicitly not vectors. It's 1,000 instances of miniature vectors moving, but it's not vectors in themselves. So what I would like to do is, you're going to go back to this field thing, and we're going to grab that evaluate field, which we did not use in the last time, but we can use now, which will take the input of the field and then the input of the points, which we can now take from our mesh surface. And this is going to now output two things: the vector, which we can just store in a blank container. And then also it's going to output the strength of the vector. And as you can see, it's a super microscopic number. It's very, very small, but we can rebuild that or substitute our own number there. Okay, so now we have a vector for each one of these points. Now we can simply bring in the move component. We're going to be moving these original points or vertices of the mesh, or we can move them by the vector. So let's see what's going to happen. Turn that off. So right now it says they look like they're in the exact same spot, and that's because if I zoom in really, really close on here, we can actually see they did move. It's just they moved that absolutely microscopic amount. As you can see here, here's the old point, and here is the new moved point. So what we're going to need to do is we're going to need to change the magnitude or amplitude of this vector right here. And we can set that to be some amount, which let's just check out what 10 will do. And now we can put that back in. And what it's going to do is it's going to change. So now maybe we can actually perceive it from the global scale. Oh, and look at that. You can see now we're actually starting to move. But right now we're only moving the vertices. We're not actually moving a mesh. That's just a series of points. So to bring this back, so we deconstructed the mesh down to its vertices, faces, and other components. So now what we need to do is construct a mesh, which by chance takes those same things. So we bring in those new vertices, and we have to bring in the old faces to sort of correlate with the vertices, so it knows which vertices are associated with which vertices. Now let's turn this off. What we have here is we have a manipulated mesh, a manipulated geometry, which we can see is also three-dimensional in nature. Maybe we can see the deformation of that. Oh, let's actually, oh well, bad practice. Let's bring that up to 50. And we can see how this deformation is pretty interesting. And moving these points, my computer's going a little bit slow, so hopefully that'll work. Anyway, so taking that a little bit further, we now have a new mesh, which is pretty interesting. One of the things I kind of want to actually let's build something kind of cool. Let's put this rotation in the center, and then I'm gonna put let's put all these guys as repel, and then I'm gonna put it below. What I can do is middle click, scroll wheel click, and lock the solver. So now I can move these points without it recalculating every time, and then I can always bring it back. So I'm just gonna bring these points down, and this guy's actually already down. So let's position them in sort of an interesting fashion, and maybe bring this guy back down to level. And then I don't think we need those 2 points. So let's see if when I bring it back, let's see what happens. So they should be pushing the surface up, and then it should be spinning around. Oh, it's, what is it saying? Oh, it's because I deleted some of those other points. I just need to reassign 1 point. Okay, I mean, yeah, that's sort of working. And let's decay, let me see the first. Let's bump this up so it's actually trying to constrain which values. You're going to find out that there's so many variables that you can change. For example, I could change the amplitude over here. I could change the strength of these points. So you kind of have to find a balance, and I tend to try to keep a couple constants in there, so because you can very easily lose track of what's doing what and what is affecting what. So my highly recommended, especially when it's something that's kind of hard to understand, is to constrain a few things and manipulate a few things, and then just be like clear about what you're manipulating. So you can see over here, we're getting something interesting. I think we can. I'm gonna move these guys up a little bit, because I don't really want to strengthen those forces. I just want to just going to bring in some Weaverbird subdivision. Let's just do that 2 times. And then let's see if that bakes out anything interesting. I mean, that is pretty cool. I made some interesting ones. I'll post some screenshots to show you some of the other ones that I've made just casually. But anyways, I just wanted to be able to show you that you can get geometry out of this. You can manipulate essentially any geometry you want. Let me hide this. Another thing that I would like to try is let's create something totally new. Let's create a cylinder that's yay high. I'm gonna hold down Control and Shift and just delete out this guy and then delete out this guy, so it's just a hollow tube. And let's bring this in as a B-rep. Let's see, sometimes you're able to achieve that B-rep to surface and sometimes not. Okay, great. So I don't really want to use all of these points I've already assigned, so I'm actually just going to delete out and clear all these values because I'm going to start a new clear value, and here we go, clear value, and everything's now going to crash because it's going to say nothing's working, but let's try something else. So what I'm going to do is I'm going to take this, and I could do this all in Grasshopper, of course, too, but just for the sake of sketching, it doesn't really matter. So I'm going to do is create a bounding box, which I'm going to populate with points. So I'm basically going to B-rep, set 1 B-rep right here, and then let's do populate 3D. So we can, now within this populate, we can get, now we're going to be given 100 points to start out. I don't think we need that many. Let's just do like 15. And we can change that from here. And then we're going to also get a seed, which we can check as well later as another variable. Okay, so now we have this series of points around this new geometry, which actually I'm going to hide both of them again. And definitely hide these guys. Well, I can just store that in a points container and then hide these two things. Okay, so now we have, you can see we now have this series of points. So now we have I've created this new widget, which I would like to test. So I'm just gonna plug this guy into this point charge. And I realize I'm gonna have to disconnect this one for it to even work, but oh, it's going a little slow because I'm also, oh no, I disconnected that. Let's put a preview on here so I can actually see this. And I'm actually going to, so I want to check the amplitude and how that's changing things. Yeah, that's kind of interesting. Let's see also if, for example, let's just lock the amplitude at 50. And I know there's a lot of problems in here. I've also been dealing with how to get rid of the collisions, but I want to try this again. The decay of the charge, of how of course, if I subdivided this too, it would be nicer. But I just want to test it out. All of this is, of course, all just experimentation and watching your computer process as you go crazy because it takes so damn long. Okay, well, that was interesting. Definitely not architecture. Definitely do not turn this as an assignment. But anyways, I digress. Sort of the point here is, so actually now I'm going to just disconnect this guy. And now let's see, for example, what happens if this is all these spinning things. What's going to happen? I mean, that looks... Oh great, Grasshopper decided to disappear. Sometimes it does that. Then you have to go like this, it's back. By the way, that's a hot tip. If Grasshopper disappears, just close Rhino, bring it back. Okay, let me Camel Clark, which is just subdivide. Let me do that twice so I can actually see something. Anyways, so I've created already a couple weird things. I don't know how long this video has been going, but I'm gonna end it there. Please like and subscribe to the content. I would play with this. There's a million things that we could go about doing. We could change all of these variables, and the ability to manipulate vectors in these almost like cloud points is super powerful. You can simulate fluidity, you can simulate some level of what physics will do. You can use these in very creative ways. I just kind of generally showed you how you can bring in geometry from Rhino and now deform it using those same principles. So yeah, I leave it up to you to explore. Let me know. Comment if you make anything cool, and please let me know. Always share with me your stuff. I'm always interested in seeing it. Anyways, thanks very much. Peace.